Okay, so we're going to talk about statistics. Big shock. So we're going to start by covering chapter 1, which is just a lot of definitions. Now when we get to chapter 2, that's when we'll start doing the R-related stuff. So that's why I went ahead and gave you stuff to practice on. I'm working on the links, the YouTube links list, so that you'll know better, like what can I watch to have somebody walk me through this instead of just reading the notes. I'm hoping to have that up by Friday. Okay. Yesterday kind of went to hell in a handbasket really quickly, so I didn't get to do it yesterday. But starting with just like the basic what is stats, there's two big branches of stats. So we sort of split into two parts. So we're going to start with descriptive statistics. That's mean, medians, modes, variance, standard deviation, z-scores, so ways to describe the study. So all of this is going to come from a framework of like a science researcher, because that's what I do. My area is computational linguistics, so I study the statistics of words, and then I also study how statistic, I guess is how I put it. So I like numbers. And so if I'm doing a study, for example, one of our most popular studies that people like is that we looked at congressional speeches. So we took what they yap about on the floor in Congress and tried to predict whether or not they would vote to go to war with a country. Okay, Congress doesn't really vote anymore. They just kind of do their own thing. But they used to vote to go to war or not. So we were trying to see if we could predict how they would vote. So do their behavioral responses does their linguistic rhetoric affect their behavioral response? Okay. But to explain that to people, I have to have some way of describing what I mean by that. So we looked at uses of third-person pronouns, he, him, her, she, it, first-person pronouns, plural pronouns, they, we, us, as a bunch of other things. But to describe that, I could have the average of each type of word. So we got their percent average in their speech of using those words. Okay. Those are normally very common. We use them a lot. So we're trying to see if that usage is different for this type of speech. Okay. So that's a descriptive stat. So it summarizes all of that data into, X% of the time we were using third-person pronouns. Your score in this class is a descriptive statistic. It's an average of all these different scores that you have. So they just describe. Inferential statistics, which then breaks into two pieces, is where I can make a conclusion. Okay, so we can describe. So that's descriptive. And conclude, I guess, is what it said. That's inferential. One thing you will learn very quickly is I can't spell, so just go with it. I like numbers, I don't like spelling. So inferential statistics is where I can say, or take an inference. So I can infer that people who use more third-person pronouns, mostly he, him, he, and him, because I don't know if you've noticed, there are not a lot of women in Congress. Not a lot of women dictators either. We're slacking on both ends. And I can infer that people who use more of those pronouns are more likely to vote to go to war, because that's what we found. Okay. So the more likely they were to use he and him, the more they were likely to vote to go to war. Okay. So that's an inference. So why the he and him? Well, most countries or problems that we have are because of dictators now. We don't really go to war with a country anymore, and those are mostly run by men. Okay. The other interesting ones were, if you talked about death-related words more, you were less likely to vote to go because the cost on the men was too high. If you talked about money, you were less likely to vote. Okay. So we're inferring that those are the important points when they're discussing whether or not to go to war because they were predicting how people voted. And so me saying more death talk equals less war is an inference instead of just a describer. So you'll see these in research papers, usually presented in something like this. This is APA style that most of the social sciences use. And so you'll have a mean and a standard deviation, and then some sort of inferential statistics, that's a t-test. And we'll get into how do I do all of those. But you always have both parts in a research paper. Because you have to explain to people, here's the summary of what happened, and then the inference part is, what does that mean? Is it important? Should I care? How does that affect the next study? So you have both pieces. Okay. So the first one's an average, and the second one is a t-test. So I could have said that he words were higher than we words. I think I was using, since this is an honors class, your scores are normally higher than my normal classes, because duh. So to do this, we're going to test samples and populations. To finish this drawing, we're going to talk about parametric stats and non-parametric at some point. So you have it all together. So how do I run any one of these studies? So this might be what I report. How did I even get to this point? So we have some kind of population of people. In our particular example, that's Congress. Okay, it's an easy population because all of their speeches are published online. They're open. The fun part about Congress, though, is that we can't say that their speech influenced someone else voting because they often go and talk to an empty room. Did y'all know this? Have you ever watched C-SPAN or anything? I didn't know this until we got started on this project. But they will go and they will talk to an empty room just so it'll be on record so they can tell their constituents that they did this thing. And I was like, oh my God, what a shame. Right? So that was one thing we couldn't infer from our study because we don't know if they're talking to other people or to themselves. Okay. So we have our population of all possible people in a group. So you have to start with a research hypothesis, clearly. So our group would have been Congress. That could be any size. Congress is a limited sample. My other research is mostly just people who speak English as their first language. That's a lot of people. Okay. You could be studying college students or schizophrenics. Could be anything. But we don't want to take a sample of everybody because usually that's not possible. So instead, we're just going to take a small group. We're going to sample them. And this is one thing the book doesn't make clear until later, so I'm going to try to make it clear now. Generally, you would like to randomly select from the population to the sample. In this chapter, it talks about random assignment, but not random selection. And so later, that might be confusing, so I'm going to give it to you now. So random selection is when I have everybody in the population has an equal chance of being selected. Okay. You almost can never do that. I think the book kind of ignores it, because it's like, I can't do that anyway. So it's often hard to sample an entire population. So one of the big things that people miss on either this chapter or the next chapter's homework test is it asks, can you randomly select or can you randomly assign? Okay. Generally, the answer for selection is no. Because it would be very hard to give everyone an equal chance to be selected.
And even if you do like a random sample, sometimes people say no.
Right. Well, this is just a chance of them being selected, and then you have the voluntary. Do they want to participate? That's a different issue. Because even if they're selected, and then if a particular type of person is more likely to drop out, you have a different problem. Research has lots of issues. We'll get some of them. 302 research methods for psych people, that's where you'll get the other half. Yeah.
So like on mine, when I, last semester, when I had people drop the survey, that would be an example of like voluntary withdrawal would not apply to this.
Selection.
To selection.
Right.
Would it apply to assignment though?
No.
Okay, so neither.
Yeah. People quitting because they're bored is another problem.
Yeah.
We have that one a lot too. So the easiest solution is to make it where they don't get credit until they get to the very end, which is a little bit of cheating. But that's what everybody does.
So then why is it hard to randomly select people from a group of population, say Congress? Why would it be hard?
Congress wouldn't. But
like you're thinking like a general like college students, it would be hard.
Right. So the question to ask yourself, which is where I was going, good point, is could I get a list of every possible person that's in this pool? So for Congress, we could. It was pretty easy. They're all listed online, and we could download everything. But if I want to study people who speak English as a first language, I couldn't possibly get a list of everyone who does that. So then I can't randomly select. Yeah?
So because the absolute size of the population is pretty ambiguous, it's hard to randomly pull from it.
Right.
Because
not everyone would have an equal chance. So even when in our department we run research studies, random selection is usually not a thing. Okay. We put them online and we let people self-select. I think more of that's in chapter 2. So a sample is a group of people that you took. So it's just a smaller portion of the population. I know that that's pretty easy. But we're going to take that sample and then do this. I don't know if you guys, anybody likes XKCD? Yes? No? Anybody? Okay, I got one. Okay, it's math nerd jokes. He loves to draw these really intense charts, and I feel like I channel him when I write these things, so let me know if the charts don't make sense. Yeah. Okay, so we're going to use that sample to estimate from the population. And as part of the sample, we're going to randomly assign. Okay, we'll get there in a second. Wait. That just repeats. Ignore the slide. It's the same as the last slide. Take it. So why would we use a sample over a population? Essentially, the answer is time and money. So testing everyone, unless it's my Congress example, is usually impossible and way too expensive. So we want to get these studies done. They don't want to take forever. They already take long enough. It would be too expensive to sample the entire population. And sometimes you just don't know who the entire population is. A population would be more accurate to an extent. And when we get into talking about test distributions, we'll talk about like what's the limit? Like how big does a sample have to be close enough to the population? Is a smaller number than you think. But the samples are much more efficient. So for our Congress study, we did take everything. Okay? But we didn't take all of Congress speeches because, good God. Right. So we talked about just the ones where they mentioned the particular wars we were interested in, which I think was Iraq, Libya, and Kosovo. Those are the 3 that they voted on. And that's still a lot of data. All right, and it was not efficient at all. It took like a year and a half. So statistics overall is mostly about numbers. But not everything we encounter in the world is a number. So I can measure a lot of different types of things, but to run a statistic on it has to be a number. So how do I make all of those things into numbers so I can get from my group of people or words or whatever you're studying? So another thing to remember is that samples aren't necessarily people. In the social sciences, they usually are, but like if you're in biology, that might be cells. And then how do I make those things into numbers? And so kind of a classic psych example is the Stroop task. So the Stroop task is when I'll give you words that are printed in their color words printed in either the color they're in or a different color. So white printed in white is a match. White printed in green is a mismatch. And you're trying to figure out word superiority. So you're supposed to say the color of the color that's printed in. But it's very hard not to read the words. So people tend to slow down on mismatches. But if you think about that study, and I'm trying to show that words have a priority over color processing, at the moment, none of that is numbers. So how do we make it a number? They use reaction time or response time. So how long it took them to say the correct color of the what color it was printed in, and not read it. So we compared matches to mismatches. It's a classic study. Mismatches are much slower, so it's harder for you to inhibit reading the word and just say the color. And my funny story about this is that my social psych professor had a Stroop cup, and so he would bring it to class every day, and I would like draw names out of a hat for us to talk because it was a grad class, but he was colorblind. And so we would always laugh like, what color is the Stroop cup today? He's like, it's still gray. And so that was one of his studies he liked to talk about. But that's how we can make it a number. And all this like making of a number is called operational definitions. Okay, and that's going to be at the very end of the notes. So we're going to talk about what are the variables and then come back to this idea. Okay. So a couple types of variables that we're going to measure. So they can be discrete or continuous. It's going to be two paths. How can I put that on here? We're going to draw here. So discrete and continuous. So as part of our study, we're going to run some type of variables. And it's here in this path because we're going to take our sample and run them through the study and then describe and conclude with the study. So discrete variables can only be one value or another, hence the discrete part. So whole numbers are discrete. How many letters are in your name, that's a discrete variable. The tricky part about discrete variables is that they can be things that we would normally consider words. So when we get into putting this into R, the real issue is going to be that things can't be words. R will automatically convert a lot of words into numbers for you, so it's nice like that. But it still wants it to be a number to do something with it. So for discrete variables, we just assign them a number. 1, 2, 1, 2. So for gender, you might assign guys to be 1, girls to be 2. It doesn't really matter. Discrete variables are often just labels. Continuous variables, it's not quite that they have decimals, it's that they could have decimals and it would make sense. So if I asked you how tall you were, you might be exactly 5'10", but you could be 5'10 and a half, and that would make sense. So here's my example of one that's a weird variable. So teacher evals. When you do those each semester, those are discrete when you're filling them out, right? You can't give a professor a 3.5. That's when you're like, okay, well, I kind of was okay with it, and it was kind of okay, and you're like deciding between 3 and 4. You physically have to pick 3 or 4. Or the scan sheet doesn't scan. But we would consider that a continuous variable because a 3.5 would make sense. So the variable itself can take on a range of values. It's just that when we made you do the study, it only was one or the other. Yeah.
Excuse me. What about something like grades, which are continuous? Like you can get an 89.67, but it will round up to a B+. Like
yeah. So we take a continuous scale and force it to be discrete.
Okay. So it's as soon as it becomes like taking the absolute value or rounding of something would be making it discrete.
Right. Well, forcing it to be A, B, C, having that label is the discrete part.
Okay.
Yeah. And that is one of those things like in real stats you would never do. So I actually really hate that we do that for grades because you don't want to go from a continuous variable that gives you more information to discrete, which gives you a lot less. We tend to like continuous variables better because they have a broader range of info. And that's more in chapter 2. All right, so those teacher evals. So the question, I guess, when you're trying to decide between continuous and discrete is, can a decimal make sense? Like, even if they can't get a decimal in the study, if I took the average and got a decimal, does it make sense? So we have this, it's called the Noir system. If you like French, it smells black, but we can go with nominal or ordinal. And then under continuous, it's interval, and ratio. Oh, spelling. 2 in the middle, or sometimes people argue about which side they go with, but for our purposes, Discrete is nominal, ordinal, continuous is interval and ratio, and then we won't get too crazy about the times that they flip sides. So nominal variables are when they're labels. So you are female or male in the study. You are, let's give you a football example, a linebacker, right? So it's this thing or that thing. Ordinal data is ranks. So technically when we just make your grades at the end of the semester discrete, it's a rank. Because A is higher than B, which is higher than C, so those are actually ranked variables. Ranked variables, first, second, third. Okay, so anytime you have something that has an order to it, but the order doesn't tell you how far apart people are. So some people can make an A and it would be a 95, other people could make an A and it would be a 93, but it's all ranked as an A. So it doesn't tell me how much better you were than a B, just that you have above that. So the ordinal, I always talk about Michael Phelps. One of these days I'm going to have to get into an example. But so he won, I think, 8 gold medals, one of those Olympics. Sometimes he won by this much, sometimes he won by a lot, but he still won all of them. So ordinal doesn't tell you how much ahead of something is, just that it's ahead. Yeah.
So like with something like a standard deviation away from something, like is that why we do the grading system like we do? Because we wanted to have like certain amounts of grades in each section?
I don't know why we do this grading system, to be totally honest. Standard deviations are going to be on the continuous side.
Okay.
Yeah. I think it's just history. It's easier that way. I don't know. I think it's dumb. That would be my best answer. So you can compare across. I don't know why we don't just z-score them, which is what I think you were suggesting. Yeah. Interval scales have an equal spacing. So 1 is 1 point away from 2, which is 1 point away from 3. So we get that nice even. We understand the distance between points. So most interval scales are numbers that you're familiar with. And so the tricky part about interval is even if we give it a scale, so teacher evaluations 1 to 2 to 3 to 4, so if I get a 4.5 rating, I know that's between 4 and 5. If you really hate a class that strongly disagree is very different than if you're sort of fine with a class and you give them a strongly agree. So we say the spacing's equal, but I don't know that it is. But most interval scales are like those, it's technically Likert, but no one says that, right? So those Likert scales, that's generally what interval falls into. Ratio scales are interval scales with a meaningful 0, where 0 means the absence of something. So temperature is technically an interval scale. It has decimals that make sense, so it's continuous, but 0 does not mean no temperature. Right? It means really cold. It means please move further south. Right? I'm not a fan of the cold weather. And just to make things confusing, often when people talk about continuous ones, they just call them scale variables. Okay, so anytime you see the word scale, they're talking about the continuous side. So if you're asked to distinguish between an interval and a ratio, ask yourself, does the 0 make sense? I know 0 length is like not a thing that you think can happen, but in theory, you could have something that is 0 length. I know. But you can't have 0 temperature. So length, weight, height, percentages, right? Those are all zeros. The one that people have the most trouble with is anything that it doesn't totally make sense to have a half. So if I asked you how many cookies you had, you could have 0 cookies. You could have 2.5 cookies. So it's actually a ratio scale. So ask yourself, could I have 0 of this? And if you can, go with ratio. Okay. Like you can't get a ticket and a half. That's a better example. So like parking tickets, right, you could get 0, and you could get 10, but 2.5 tickets doesn't, like I can't actually get a half, but an average of 2.5 tickets would make sense. Oh, and I totally had forgotten I had this cookie example. It's a little early for cookies, but so nominal would be like the name of cookies or types. You can have people rank their favorite cookies. Interval would be like a temperature of them. I don't have a good interval scale. Right? Or if people ask how strongly they agree with the cookie, I don't know. Right? Ratio, how many are left? Or how many do you have? There will be lots of food examples. They're normally about cheese, but I'm out of cheese examples today. So the point of this, why do this? That tells me what type of descriptive variable to calculate and what type of inferential stat. So that's why I kind of have it here between the sample, who's going to take these variables and come up, like give you an answer for them, which will then be used to decide what type of statistic am I going to do. That's not always clear in the book, because they're like, oh, we'll just say that for later chapters. But if I have this type of independent variable and this type of dependent variable, I will do this type of test. And that's really what the semester is about. Like if I have this IV and this DV, here's the test you do. If you have this IV and this DV, here's the test you do. So that forces us to pick IVs and DVs. I'm out of room on my thing here. We'll go over here. Okay, so for a sample, we're going to do a particular case. And they're both going to take the DV. I know it looks like I drew a house. It'll make sense in a second, hopefully. So an independent variable is the one that you are manipulating or categorizing or forcing to be the cause. So independent variables are thought to be the cause of the DV. Even if you didn't run the study in a causal way, people still think this causes this or this influences this if you don't want to use cause. So for it to be a true experiment, I hate this phrase, but true experiment, quote, air quotes, it has to be manipulated. Okay. Meaning you took the independent variable and some people got this version and some people got this version. That's a lot of our research is based on those sort of categorical distinctions. Like I gave you this and I gave this person this and here's what happened. So to be a true experiment, it has to be manipulated. So I could give some of you, I don't know, I'm not going to do this, but I could give some of you the specific type of test questions and give you different types of test questions and see which test questions were better. It's kind of not fair, but we could. So I manipulated who got which questions. But if I decided I wanted to compare this class to one of my regular classes, that wouldn't be manipulated because I didn't change who was in each class. So if we're comparing, what's another study that we did? Oh, we looked at the PASS program and how well it worked for different types of people, so non-traditional students, regular students, and then we looked at minority groups. I didn't manipulate that. You just are those things as a quasi-experimental variable. So as a naturally occurring group. Yeah.
Wouldn't that also be the you categorizing a group because you're like, oh well, you responded to this question like this, so I'm going to categorize you as part of this group.
Yeah, that happens.
Yeah. Okay.
So Dr. Hudson and Wisenhut are in the body disorder lab, and they will often give people a continuous scale, but then only take the top X% to test.
Oh.
So they're categorizing them as high body concern groups. That does happen. And so these are for studies that have categorical IVs. You can have continuous IVs, but then you really aren't manipulating, right? You're measuring them and then seeing if they influence. So that's going to be a correlational design. Okay. So the kind of complexities of statistics I can't quite draw on the board, but I'm going to try to get it into a nice, somewhat flow chart way. Another thing that the book forgets to mention and then asks you about on the homework is that when the IV is categorical, so it can be categorical or it could be continuous. I've got the categorical version drawn on the board. Those kind of groups are called levels. So I could make you in the experimental group, or I could make you the control group. That's sort of like a classic study where you have some people who get the manipulation and some people who are just controls. So in the case of their body concern group, they take people in the normal range, people in the abnormal range, and they test what happens. That's called a level. So we'll ask you on the homework, what are the levels of the variable? What all they mean is groups. What are the groups? So my dependent variable, what I'm going to do is take my groups and measure them on something. And see what happens. So are there different scores for each group? So there are different descriptive scores for each group. Okay, so I'll calculate the descriptives and then see if they're different using the inference statistics. And those are generally going to be ratio variables or scale variables, interval, whatever you want to call them. So it's generally continuous. And that's where this distinction comes in. So I forget where this is in the notes, but I already have it on the board. So if I have a parametric stat, the dv is continuous. It's all about the dv. The IV can be continuous, it can be categorical, doesn't matter. In non-parametric stats, the dv is discrete. That's the distinction. 90% of this class is parametric stats. We're going to get to chi-square at the very end, and that's non-parametric. So the IVs and the DVs could be continuous or categorical, discrete, and that is what determines which stat I'm going to do. So depending on the way you run your study from your sample, those variables you picked determine which stat we're going to pick. And so I just have the examples of the tests we're going to do. So interval ratio variables, those are continuous. We're going to do t-tests, ANOVAs, regressions, and correlation. If I use a nominal variable, we're going to do chi-square. So I can pick any of those two, like discrete and continuous, and those combinations determine my inferential stat. Now, one of the other big problems that we have is confounds or noise variables. Excuse me. So things that systematically vary with the IV. So the biggest problem with studying any type of school work is aptitude. It's a systematic variance problem. So clearly, this class is going to have a different set of scores than the same course, but your general population. Okay? So we'll always use, we call this the smart kid factor. So we'll always use previous GPA or ACT scores to sort of control for the fact that some people are just better students than others. So when we did our past study, that was one of the biggest things that we had to do to make sure that we weren't saying that only the smart kids went, and of course their scores went up. Right? So it also affected the people who were making C's. So we're going to try to control them or randomize it because it confounds our other measures. And sometimes this is called the third variable problem too, which it makes me laugh because it's coming from the third wheel idea. So it's that extra variable that you don't want that's there. Okay. Before I go, this is going to be a slightly different section. This could be anything. It could be time of day. In our studies, it sometimes is dialect can cause us some problems, handedness, boredom. I mean, there are lots of things that could cause problems. Okay, where we got? Oh, I'm good. So let's see if I can get through at least the next couple ones. Reliability and validity. So now we're still talking about variables and measures. We're still kind of here. One problem that people have is that you have to have measures that are good. So I could take people, give them a sample, run them through my different variables that I was interested in, and then run this test, and it could totally be garbage because the way that the variables were written was bad. This is what a lot of the research I do. I look at scale development. So how people come up with those scales that you take, and are they any good? Okay, so things have to be reliable and valid. And you hear that in like intro psych, and you're like, yeah, whatever. But on this end, that's something you can test, is how reliable and valid they are. So reliable measure is consistent. So I always tell students never pay for the GRE twice unless you were violently ill the first time, because it is very reliable. It's extremely consistent, people's scores. Plus it's expensive. And so you'll get the same score over and over again. And standardized tests are like programmed to be reliable, because if you're going to pay for it, it damn well better be a good score, right? And so that's what a lot of people at Pearson, ATS spend their time doing, is making sure the questions are reliable. Valid measures, this is a little harder. Reliability is actually kind of easy to test. Give it to people twice, make sure they get the same score twice or close enough. Validity is a little harder. So this is that it measures what it's supposed to measure, and there's like 10 different types of validity. We're just going to kind of talk about it as a whole, validity. So face validity is it looks like it measures what it's measuring. Right? So measuring tape should measure height well. I always joke that shoe size is actually mildly correlated with intelligence in kids, because as they're getting older, they're learning more facts about the world, and they're also growing up. But then that would make Paris Hilton really smart. She wears 11s. And then I'm like, so do I. Maybe there's something there, but not really. So that is a reliable measure, right? You pretty much stay the same size, but it's not a valid measure of IQ anyway. And then for at least the women in the room, men, you guys got it made. But unreliable measures is sizing of clothes. Yes. Yeah, you go to one store, you're like, what? I fit in these. What? You go to another store, and it's like 3 sizes larger, and they're just totally inconsistent. They are valid measures. They're measuring what they're intended to measure, but they're not reliable at all. So anytime my husband's complaining about finding pants, I'm just like, you're measured by the actual size of the pants. This isn't that hard. Where are the 32s? Like, he's just complaining because they can't make them like he's tall and skinny, and that's not a combination that he seems to find. I'm like, yeah, it's such a hard problem in life. Right? So a famous example is the Rorschach. It is not reliable or valid, really. So it's not really reliable because even though they train people to give this test, it doesn't necessarily get the same answers every time, and the validity of it is kind of like, meh, what does it actually mean? It's an easy test to pick on. But there are lots of things that people use on a regular basis that are sort of iffy to use for what they use them for. So a lot of places give personality measures before you can get a job. Sometimes it's unclear if that actually is helpful for picking up the right person for a job. My better half recently got a job with the feds, and I was like, they gave you the what test? It's like, do you know that that's not supported at all in any way possible? Cool. I'm glad you passed it. What's the other one? Oh, I just had it in my head. Brain fart. Not the Wonderlicht. That's also terrible. Never mind. I can't remember. Right. So there are lots of tests that people use that are sort of like, oh, I don't know if we should use that anymore. Yeah.
Is it Myers-Briggs?
Oh, I hate the Myers-Briggs. I hate that test. It's one of those ones that like half the time it seems to predict things and half the time it doesn't. And so I'm on the like, this is, why are we still arguing about this side? But yeah, that's one of the ones that's sort of questionable. I think it just depends on the way you do the study, which means that it's definitely on the like, oh, is that valid side? Mm-hmm. Right? It should be sort of consistent across different measurements. Okay. All right. So that actually would be a place to stop so I can answer some questions on dealing with Launchpad. Yeah, so we ended here talking about validity and reliability. And we're moving into hypothesis testing. Okay. So I don't know if I can remember quite the whole drawing, but we talked about descriptives. So descriptive statistics being like mean, standard deviation, variance. And then inferential stats, T, ANOVA, etc. And we talked about parametric and non-parametric. And that's influenced by the type of DV. Right? So this is for interval. Oh, we just said continuous. So continuous DVs, and these are categorical DVs. Then we talked about sampling from a population. Sample. Talked about random selection. That's not a thing you can normally do. Okay, we have an example of our IVs measured by your DVs. And this was types of variables. I won't redraw that whole part. We talked about IVs have levels, so each group is considered a level, and I think that covers everything from last time. Because we spent a lot of time on the types of variables, because the types of variables that you include in your IVs and DVs control what types of statistics you're going to run. Okay? So this section over here is really more the research methods side, but you can't really talk about stats without talking about research methods. So we'll talk about, like, here's the type of research methods we do to get to these statistics, and then in a research methods class you'll cover more of the problems with the types of designs. And then we also talked about noise variables. I think that should cover it. So the whole point of inferential statistics is hypothesis testing. All right, let's hear it. So we're going to come up with some type of hypothesis to test, but that's also influenced here. So I'll also put it here. Oop. I will not spell. Okay. So hypothesis testing really starts with the design of the experiment. So you have some hypothesis, and then you're going to run these variables, but then it also influences the type of test that you run. And the point of hypothesis tests is to draw a conclusion. That's why it's all tied to inferential stats. Because we're trying to infer if this relationship is true, supported. Right? We don't ever say prove because it's a science. If these two groups are different. So all those claims that people make, we're trying to find a way to support it with numbers. So coming back to something we started on here under types of variables, how do we assign numbers to things? So we talked about categorical, discrete variables, continuous ratio scale variables. But when we make them a number, it's called an operational definition, which is just a fancy way of saying computers like numbers, so we're going to need it to be a number to run tests on it. If it's a discrete variable, sometimes the number is just literally like, here's group 1, here's group 2. The nice thing about R is that we'll do a lot of that assigning for you. So if you import something with text, like a group label, like male, female, it will automatically make it a numbered variable with a label on the top. So it's nice because it'll sort of auto-assign the numbers underneath, and you don't have to worry about it so much. But we've got to define our variables. And so an operational definition is how we're going to measure the variable interested in. So if I'm interested in measuring IQ, I feel like that came up in this class, maybe culture fair tests. Maybe that was yesterday. If I want to measure intelligence, that's one of my independent variables. Or if I'm a dependent variable, well, I have to find some way to add a number to that. So we could use the Stanford-Binet, the WAIS, the WISC, the Tony. There's a bunch of different tests. And so those are the way that we're operationally defining them. So we're giving it a variable type. If you're interested in depression, so I have a friend who studies logotherapy. I have lots of examples from that because we do a lot of work together. And so he's interested in how your meaning in life, your purpose in life, changes negative outcome variables like depression, suicide, PTSD. So some of the textbook definitions of depression is diminished interest in activities, significant weight loss. Well, that's pretty easy to add a number to. Right? Been weighing people before and after. Fatigue is a little harder, especially if you're a college student. Right? You feel like you're tired all the time, especially when it's like that week we have 6 tests. So how do we measure fatigue? Do we have a scale? Do we just ask people, how do you feel? Do we make them give you a number? And then it gets harder. Feelings of worthlessness, recurrent thoughts of death or suicide. Like, you really want people to count. How many times did you think about death this week? So we have to consider the way that our variables are measured, because that influences the type of test we're doing and the outcome we get. So operational definitions are how we give it a number, and that can sometimes be tricky. So do we want to make it categorical? Do we want to make it continuous? Kind of thing. So this is from the book, so it's a little silly. But let's say we're trying to develop a hypothesis. So we have to have IVs and DVs. So IVs predict DVs. This is something I know all of you know. Okay. So I might say that gender would predict who uses an ATM faster. So I guess you could think that girls like to talk, so maybe we're distracted. I don't know. Or we're better at pushing buttons. Is that the book? But gender is going to be a categorical variable, and so we're actually going to see who's different on those DV variables. Okay. The amount of willpower, that could be a continuous variable. We measure people's willpower somehow. That would be a hard thing to operationally define. But then how much are they smoking if they're wanting to quit? Okay. So in all these cases, these are words. Right? These are variables that are words. Level of joke-telling ability. But we have to find some way to define. Okay. Now, number of friends, that's a little easier. You can just ask them, how many friends do you have? Right? But especially this parking one this week, right? Oh, it's a madhouse. So level of caring by administrators, like we'll say they don't care, that causes a parking problem. But how do we measure their caring? How do we decide there's a parking problem? So a lot of statistics, a lot of the research design is determining that piece, like how we're going to measure what we're interested in and given a number, and then that changes what stats you do. So a couple different types of research design. So that's really affected here. What are we doing with our sample? So we've got experiments. And this is where it's going to talk about random assignment. We talked about random selection last time because this is one of those things that the book is just like kind of glosses over. So random selection is where every person has an equal opportunity of getting picked. Random assignment is here. Random assignment you usually have control over. And that's a good thing. It helps. So random assignment is when you put them randomly in groups. So this only works for categorical variables. You can't randomly assign someone to be an IQ of 115. That just doesn't work. So we're assigning them to one of the levels of the variable. So that really is like a traditional experiment, but like traditional science. I use this loosely because I don't like whatever. Like, why are we calling it that? But where you have like, here's my control group and here's my experimental group, and I manipulated it so it's all causal, and I'm going to put half of you here and half of you here randomly. The cool thing about computers is that it makes it really easy. So we have this study where we're looking at 47 different scales. I don't know about any of you, but I don't want to sit through 47 different scales. It's like 1,000 questions. I don't even think the MMPI is that long. So we don't want everyone to take it because they would kill us. They just like, I just want my intro credit and I want to get out of here. Right? So we have it randomly assign them 10 of those scales. Okay. So that's a way we're able to randomly put people into different scales. Okay. It's not really a level of the IV because it's continuous, but it does randomly help us make sure we don't have different types of people on different scales. Okay, that is different from random selection. Random assignment, you have control. Yeah?
So in the IQ study, would let's say I try to pull a random sample, and then I pull like a random sample, but then I have to find out what their individual IQs are. Would assigning them to a level of the variable be saying like, okay, you're in this bracket of IQ, you're in this bracket?
No, that's going to be, since that's a quasi-experimental, like it's a naturally occurring group, they are in this bracket, you can't randomly assign. So I can't randomly assign a gender.
That makes sense, yeah.
Because that's a naturally occurring variable. That was actually one of my next sentences.
Oh.
So you have control of a random assignment unless it's a naturally occurring variable.
Okay.
Because you can't, like I said, the way I always think about that is like, can I make them this thing? If you can't make them, you know, I can't make their IQ be 100. Yeah, or I can't make you be female for the day, or I can't make you be Republican or Democrat, like that's just a naturally occurring thing, then you can't change it. It's not randomly assignable. The good thing about experiments, though, why people strive to do them, and they're like the golden standard, is we're able to make causal statements. So this causes this. If you don't have a true experiment, you're supposed to say this influences this, or it changes with this other thing, or predicts this, but we're not saying it causes. Most of science, I hate to say, is not totally causal because you just can't. So like I said, I can't randomly assign you to gender. I can't randomly assign you to give you cancer. So people don't like that. And so most research is actually quasi-experimental or correlational. The good thing about experiments, though, is they'll let us control confounding variables, and the randomization really makes this what it is. So it helps to have it randomized because an equal number of weird people go into each group. So the good thing about randomization is it helps control all that noise. Because if you're going to have weird people in your study, but at least there's an equal number on each side. But that's like not always doable. So often our studies are correlational, which I think is, in a couple slides. Okay. One problem that people have is self-selection. And this is true for every intro study here. So if you took intro to psych and you picked the studies you wanted to be part of, most people go for the online studies because you don't have to go anywhere. And then after that, it's whatever time works best for you, or whichever one sounds maybe like it won't be the most boring thing you've done all day. And that's self-selection. So it doesn't always work. And so this is a goofy example about Guitar Hero players. So we let people who self-select, people who play regularly, people who never play, and then measure their reaction time or their response time to hitting the buttons. People who play are clearly going to be better, right? So self-selection is bad. So instead, what we could do is randomly assign them and ask them to play. Like here, you guys go practice. And you guys hang out, watch Netflix. And then we measure their reaction times. So we might have people who play regularly in both groups, but at least it's even. So when we randomly assign people to groups, you control for the fact that there's this natural dichotomy, and you shouldn't let people self-select. Right, that's why you should take all of the polling that people do, especially if it's on a major news station, with a grain of salt. Right? Because people self-select to answer those polls. That Truman defeats, or Dewey defeats Truman headline, that's kind of a famous example of when they got it really wrong. So, but if we're going to do an experiment, let me kind of make some. Don't actually erase this part, I'm just going to make this bigger. Those can break into between and within. So this is all still like kind of under here. I have correlations. So between groups designs are when you have different people in each group. Okay? They don't take both halves. So between groups designs can work for quasi-experimental designs too. So if you have girls and guys as your study comparison, you cannot be in both groups. Right? You are one or the other. If we're talking traditional experiments where I give some people one test and some people another test, they don't see both tests. So my example study with 47 scales is actually both types of designs at once. So you can mix and match these things. So different people are completing different scales, but they also take several of them. So between groups is where people are only in one test half or the other, not both. Within group designs, people are doing all parts of the experiment. So they're doing multiple pieces. So you can think of a class as a large within group test, because you're going to take several exams and several quizzes and several homeworks. So you're in all of those, hopefully. Don't forget to do one of them. A between groups design, you would only take exam 1. But not everything can be done through an experiment. We kind of talked about why. Sometimes it's unethical, like the cancer idea, or hey, you start smoking so we can study smoking cessation. Or it's impractical, like you just can't make that happen. So instead you do a correlational study. Okay? So experiments are true experiments, or when you're manipulating what group they're in. Quasi-experiments are sort of halfway in between these, where you have natural groups. Correlational studies are you just kind of measure things how they are. So on the homework, you can call it correlational or quasi-experimental. They're not quite the same thing, but the book treats them as the same. Both answers are right. So most of my research is correlational stuff. We just study how things are. So we study the way people talk naturally, or in the depression studies, we study their current levels of depression, suicide, meaning, and purpose. Right. We've tried manipulating it, but it doesn't work. Yeah.
So is the reason a causal experiment becomes a correlational experiment because with correlational experiments it's natural variables, so you can't control for sure all the confounding variables?
Basically, yeah.
Okay.
You didn't manipulate it.
Yeah.
So it could be something that is just because that's the way things are, in a sense.
Mm-hmm.
Yeah. So mostly people just talk about they influence each other. Or like in theory, all those cancer studies, unless we're talking about the ones on animals where they did give them cancer, are correlational. So they, when they tell you smoking causes cancer, well, yeah, because you don't just, normally people start smoking first and then they get the cancer. But you never know. People could get cancer and then be like, well, whatever, I'm gonna start smoking. So, but generally it has an order time-wise. But those are correlational studies. So, sort of famous studies about video game playing and aggression. They are correlated, but that does not mean that it's causal. Right? So there's a ton of research on this, and none of them agree. Like, half of them say it is causal, that if you play something more violent, you're going to act more violent, but you're going to act more violent in the 15 minutes after the study, but it's not a continuous thing. Or there's some people say people who play those violent games are just attracted to them because they're naturally more violent. So that's one of the problems that research has, is it's often correlational. Okay. And I don't think it's actually this perfect. That's such a cute graph. It's really very messy, but that's the idea of a correlational design. All right, and the last little piece is kind of on this end. So I would actually put it here, because it's part of descriptives. But it influences this stuff. So we'll make a cute triangle over here. If you don't get the flowchart, it's okay. I kind of made it up on the fly. So an outlier is a person with an extreme score, persons with an extreme score. They can be very high or very low compared to all of your other scores that you have in that sample. And outlier analyses allow you to understand, why is their score so weird? And we actually normally do this as part of data screening. So we'll look at the data to make sure that it doesn't have any typos, or some of the software we use will rescale variables and you didn't want it to. It gives it a 0 to 4 and you're like, that's supposed to be 1 to 5. What are you doing? And then we look at outliers. So people whose scores are exceedingly high, but you can also use that as data. So why is their score so high? Is it a typo? Is it because they weren't paying attention? Is it because they really are a very extreme score? So it allows us to understand what the deal with them is, because they really influence your inferential tests. Okay. So outlier scores are extremely problematic for parametric statistics especially. And so people are interested in, why are you an outlier? And often it's because they're freshmen. No offense if I have any freshmen in here, but God, could you just read the questions? So I'll have people take our 10 scale thing. Should take about half an hour and 4 minutes. Because they just like clicked on a bunch of them until they were done. So that's an outlier, but it's an outlier because they didn't try, not because their scores are crazy. So kind of recap everything we've covered in today's lecture. So operational definitions are ways to give numbers to variables to determine the scale that they're going to be in. So if you give them 1 and 2, it's a dichotomous variable. If you make it decimals, it's a continuous variable. This emotion. It's like mini theater up here, building emotions. The types of variables are determined how they're used in the experiment. So categorical variables for groups are the IV often, which then influences the types of research. Okay, so all those are kind of tied together. So where you start with your operational definition and the influences the research design, the variable types, and the research design, which then tells you what type of stat to do. Okay, so operational definitions are kind of like the starting point for your hypothesis.